So welcome everyone. This is going to be about the terminal, so I'm going to start by opening the terminal. Okay. Just a sec. All right. So also going to open a few more on my demos. And here's our slides in the terminal also. So, I divided this talk in 3 parts. I'll briefly introduce myself and what I'm going to do, teach you the basic tools of what you need for doing such cool stuff, and then I'm going to deep dive into the techniques and many demos. So, who am I? My name is Hamza, also known as Tenchi on the internet. Here's my Twitter and blog. I've been in CodeStar for about a year now, and I really like terminals. So, like I said, I love to play around in the terminal. I do most of my things in there, and sometimes I just come across a tool that I find really nice. It's like black magic. I don't know how they do that, and that really inspires me. I really want to learn how they do that and do it myself and do it even better. Some of these are open source, some of these experiments to force me to make better code and not just experiment away with crappy code. So if you want, you can check my GitHub in the bottom. I'm going to start by showing you stuff that already exists out there. So you can, if you want, pop up a terminal, install the tools yourself and try them. So have you ever woken up in the morning and you thought if you squint hard enough you could see the code that makes our world? So if you just type C matrix in the terminal, then you can. If you sometimes want to take vacation, for example, go ski in Switzerland, you can use GNU Ski and just ski in your terminal. Then there's some stuff that is a bit more useful, like Figlet. You can write big text. Of course, this is Unix, so you can use pipes. Here's a cow saying code in comedy, and we want it a bit more lively, so here's a lolcat version of it. And as I said, I use the terminal for everything that includes Reddit. So here's a client called RTV. You're going to go on the Scala subreddit, and it's all in your terminal. You can just browse Reddit there. So if you look around, you'll find many of these really cool tools. And I wanted to do them myself, so this is what this talk's going to be about. First, we need to master the terminal, so we need to know about the characters that are displayed there, how they are rendered by the terminal emulator. So first, we're going to start with ASCII. I'm sure everyone is familiar with ASCII, so I'll go really quickly over its history. It started as a 7-bit encoding. So with 7 bits, you can encode 128 characters. That's a few control characters, the alphabet, a few symbols, the numbers. And then when processors got better, they had more bits. They wanted to align the characters with 8 bits. That's how your memory is aligned. So each company basically added their own symbols. So 128 more characters. And every company took this approach differently. So we have Commodore with PETSCII and MS-DOS and every IBM compatible PC with code page 437. And basically because they don't have a graphical interface, they took the opportunity to use that second half of the ASCII table to add fake graphics. So lines, intersections, dithering blocks. On the other side, we have Macintosh, which already had an interface, so they took advantage of all that free space in ASCII to just add accents so that they can support many languages. And nowadays, ASCII is standardized by the ISO, and you have many variants. They mostly all focus on accents. So what does code page 437 look like? We first have control characters, some numbers and symbols, the alphabet. Then this is the second part, the extended part. We have some accented characters, and this is what interests us here. It's all the drawing things. So we have lines, blocks, and what can we do with that? We can just draw boxes in the terminal with text, and we can create fake colors. Like here we only have black and white, but we have 9 shades from white to black with dithering characters. Maybe some of you have seen this stuff before. This is also using code page 437 characters to make those boxes and progress bars. And then you can be a bit more creative and do fun stuff like this. So I'm going to show you a simple project I did at first using only ASCII. So if I go to my code and comment here. So if I show you this file here, it's an abstract representation of my logo in hashes, and I made a tool that will parse that and create a graph, and then animate it using a breadth-first search to draw it dynamically. And as you can see, I'm cheating a bit here because we're just spamming lots of states, and then it looks like an animation. So we're going to learn how to not fake that. I don't have so much time, so I'm going to skip over Unicode. It's just you have infinitely more symbols. Just be creative with it. You just have to explore pages and pages of specs to find symbols that can interest you. Here's a VT100, or at least the best I could do to draw it. What is a VT100? It's just a terminal, so no processing, it's just a screen with a keyboard. You can connect with it to a mainframe server, because computing is expensive in the 80s. And the server does all the computations, and you can give commands from the terminal. And why is this interesting for us? It's because this was the basis of NC escape codes. This machine was the first one to introduce special commands that programs or the server could print to you as text, and your terminal will just catch them, not print them, and do special things with it. So move the cursor around, use different colors of text. And this is what they look like. It always starts with an ESC symbol, so a hex 33. And a left bracket, and then you have you follow with numbers, letters, and you have a whole spec for that. Of course, you have a page on Wikipedia, but it's not the most complete. So if you're interested, I'd recommend reading VT100 manuals from really long ago or external manuals. And now, using these NC escape codes, we can do fun stuff. So if I come here and I do a printf with an NC escape sequence, and I'll use 2J, which is the code for here, it clears my terminal by printing text, which doesn't appear. So that's what my terminal emulator intercepts. By the way, we say terminal emulator for all programs that have a terminal because they emulate the VT100, basically. And next, I'm going to show you the same demo as before, the logo one, but this time using NC escape codes to move the cursor back to the beginning, and then we don't spam the terminal. It's really an animation that takes place here, without moving stuff. So that's kind of neat. Next, I don't want, when experimenting, I don't want to print manually all those codes all the time. I'm going to forget them, there's so many of them. So you want to use a framework. If you look at most of the tools that already exist, they're all written in C, and they use end curses, which is really old and not really supported on all the platforms. And the API is really, really boring and old to use. So I want to use Python, and of course there's a curses binding for Python, but it's a literal translation. So if I just want to initialize my screen, I have to select a whole bunch of modes that you just have to know you have to initialize. And then every time you want to print something on the screen, you have to initialize a color pair. You only have so many color pairs available. Yeah, it's just a mess. And when you finish, you have to remove all the modes you put. I don't want to do this all the time and copy-paste code. So I created my own framework in Python called CurseBlocks. The goal was to have an easy mode where you just start a with block, so we have a separated context. When you're in this block, the screen is initialized. You can do stuff really easily with put. You can just put text anywhere on the screen with any color you want, no initialization. And when you're out of this block, the screen is restored to its initial state. I also wanted to experiment with Scala, and you don't have anything curses related on Scala so far. Of course, maybe you can find some Java implementations, but who wants to do Java stuff in Scala? So I wanted to do my own fun Scala library, and we're going to see later how fun it is. So now that we have tools, we're ready to delve deeper into the dungeon. And I separated all the demos in 3 generations to show the progress of the techniques I discovered. Here's a little preview of what's awaiting you. First generation of technique is really basic. It's using those blocks that you saw before. In the terminal, letters have a ratio of 1 to 2, so they're twice as high as large. So when you use simple blocks like this, it looks really squished horizontally, and you only have 16 colors, so you're pretty limited. You can fake out colors by using these dithering blocks, so you can have a background color of blue and a foreground of yellow, and in between you have something that looks like green because you go far away. So what did I do with this? It's called Almonds. It's a Python fractal explorer. You can install this, it's online, so if you do pip install Almonds, you can use it already. And it looks like this. So you have a nice neat splash screen, and then you have the Mandelbrot fractal in your terminal. So this is all text again, no cheating. So you can just go around, zoom as much as you can until you hit the floating point precision. And then when you find some place that you find is neat, you can just press H. A nice progress bar will come up and render that scene in PNG and open the file at the end. So this is what it looks like when you don't have small pixels. And you can change palettes and do fun stuff with it. So feel free to try it with pip install Almonds. Next up, we have the second generation of technique. One day I woke up and I had this idea to use Unicode Braille. So Braille is the writing system for blind people. You have 8 possible dots that you can raise or lower, and you feel them with your fingers. And of course, in the English alphabet, you only have 26 letters. But in the Unicode standard, they decided to encode every possible combination of these 8 dots. So we can use that in our advantage. If we have some random pixels, we just write in binary a 1 when the dot is raised, following the Unicode order. Then you inverse it, you add an offset, and here you go. This is a Braille character with the same pixels as what I had as an input. And when you do many of those, you have a one-to-one mapping of pixels to characters. But you can't use color. Like, you can only color a whole block of 8 dots at once, so it's not really interesting to experiment with. But here you see a rendering of the CodeStar logo in Braille. And the only project I did, except for a converter from image to Braille, was a Surveyor, which is a traceroute parser. So traceroute is a Unix tool which shows you all the hops between your location and the place you try to reach, show all where the packets go, basically. And I did this hacker, in the movies they always have hackers with nice screens and displays and stuff, so that's what inspired me. So if I pop up the demo, here we have a world map. You can see the day and night line. I did a request to Japan, and you can see that it's traveling all the way through the UK, then to Russia, and then finally it reaches Japan. And this is all vector behind it, so you can zoom as much as you want. In the terminal, this is again Braille characters. I'm not cheating. There you go. So that was fun, but not being able to separately color each pixel is not really interesting when you want to do crazy things. So I came up with this third and final generation. This time we only have 2 pixels per character instead of 8, but we'll see that they're much better pixels. I'm using this character here, which is an upper half block. So when you have a 1x2 block, then you take half, you have a 1x1 ratio, so it's really squares. You can control the color of the upper pixel using the foreground color, and the bottom pixel is just showing the background color because there's nothing there. And using that technique, we again have a one-to-one mapping of pixels to characters. And what about colors? 16 colors is really tiny, and I discovered that Xterm, which is the default terminal for X server on Linux, has a 256 color mode. Which is basically a palette with fixed colors, and they're pretty much in a random order and then numbered. So it's really hard if you want to map RGB to this palette. So what I did is a function that takes an RGB tuple. It will compute the distance between that color and every color in the palette, and then when it finds the closest, it keeps it in memory. So next time you call it, it doesn't do the computation again, and that made a really fast one-to-one mapping of RGB colors to terminal codes. And you could say that, hey, this is worse than the Braille one because you have less pixels, but This time we have separate control of every color, so we have a real canvas where you can just paint stuff in the terminal, and that's basically Turing complete for graphics. So the first example I want to show off is Orbiter, which is an old school module player. Modules is a format for music from the 80s. It's like MIDI, but it contains its own audio samples, and that was popular in games and demos at the time. So I call it Orbiter. If I just take so here's a module playing in the terminal. We have a fast Fourier transform to see all the frequencies and do a spectrogram live. And this is old gen, it's the Braille one, but then we can use the spectrogram to see a heat map, basically. This one. So this is a heat map of the sound. On the right is the treble, on the left the bass, and you can see live with pixels in the terminal which frequencies are playing. And the apogee of this project was the player mode, which takes a module file, and you have a tiny player in German. You can see the separate channels, the frequency, a progress bar, the comments, all that stuff. Next up is the Pokédex CLI. That was when Pokemon Go was so famous when it started. I took the opportunity to do an open source project, which had some traction on Reddit. It basically uses a free database that you can find online to do some queries. So if I look for Pikachu, I can have the Pokédex entry of Pikachu. I can search by number and show the mega evolutions. Oh, the screen is a bit tiny here, so yeah, basic but fun. Next up is a project that was featured in the Scala Times. I was really happy to learn. If you're wondering how I did this newspaper with characters, it's using Unicode. For mathematics, we use like nice calligraphy symbols for sets and stuff, so it's all in Unicode, and Chinese astrology symbols for the lines. So this project is called Curses. It's basically curses for Scala with no dependencies, done from scratch using ANSI escape codes. It's as simple as the Python one to use. We have a curses block, which gives us a screen, and we can do queries on that screen. So when we do dot size, it will send an ANSI escape code to the terminal. The terminal will respond with the size of its window in the user keyboard. We intercept that. It's all done behind the scenes. And we can just simply display text wherever we want with whatever colors we want. So quick live demo of this. First up is the demo, the code I showed you just earlier running live. So it's just a text in the center asking for a key. The next one is a bit more fun. So this is the game of life in Scala in the terminal. You can see it has quite a lot of frames per second, so you can do fun stuff with that. Next up is Onions. It's a framework which is all about the UI. And I wanted to have nice dashboards in the terminal that you could SSH to, because when you SSH to a program that sends you ANSI escape code, your terminal still interprets them, so you can do fun stuff through SSH. And for dashboards, I just implemented a bunch of crazy widgets. I went wild with that, so let's just show you it's easier. Oh, I can't do that here, it's too small. So here's the dashboard. In the terminal, you have a text widget with justification, write a line. You have reactive components, so your name is a reactive label. If I write code in comedy, it changes live because it's observing that input. We have radio boxes, a histogram showing stuff over time. We have themes, so here's the MS-DOS theme. Checkboxes, 7-segment, bars, scatter plot. And it supports tabs, so here I have 2 tabs, and this is a PNG widget live in the terminal. And here is a heat map of that scatter plot, and with this scroll bar you can just choose the blurriness. So this is Onions. It's on GitHub, feel free to play with it if you like Scala. And finally, my last demo is about Svordom. I wanted to make an old school RPG game in the terminal. And basically it's a 3D raycaster, so if I run it, We have a nice splash screen with an animated line, and here we are in the world of Svordom. It's an interactive 3D maze with characters, again, no cheating. And yeah, it even supports anti-aliasing, I don't know if you can tell. And dithering and all that stuff. So this is how I have fun in the terminal. So that was my talk. If there's any question, maybe we have a few minutes.